So in this question, we have a race car, and we know that the average velocity for the whole race is 200 kilometers an hour. So, and then it's sort of broken up into two parts, 50 kilometers and 50 kilometers. So in the first part, we'll break it up into two parts. And like we have been doing, we'll write down our variables, delta t, delta x, and v for both. We also, for this thing, have the totals. So let's just kind of look at the totals, where we'll write down the delta x for the whole thing, delta t for the whole thing, and the average speed for the whole thing. And let's see what we are told in this problem. So it tells us that the race car driver must average 200 kilometers an hour to qualify for a 100-kilometer race. So the average speed for the whole thing has to be 200 kilometers per hour, and it's got to, the race itself is 100 kilometers. Okay. So that we know. Because of engine trouble, the car only averages 170 kilometers an hour in the first half. So the speed for the first half is 170 kilometers per hour. And so we also know that it's the first half, so that's 50 kilometers. And then what it's asking us for, what average speed must he maintain in the last 50 kilometers? So we know this is what we want to know, and we know this is 50 kilometers also. All right, so that's everything we know about this problem. So the question is, how do we find a path to what we know? We can't find v because you always need two variables in order to find the third. So the question then becomes, how do we find t, and can we find t? Well, we don't know this t, and we don't know this t. But as we can see, the overall sort of underlying relationship, v equals delta x over delta t, is the underlying relationship. So we can actually use this to find delta t in both of these, the first part and the total. So in the first part, rearranging that equation, we get delta t equals delta x over v. So we can say that this is 50 kilometers over 170, which equals, a quick calculation will reveal, 50 divided by 2.941, 0.2941, and this is in hours. And over here, delta t equals delta x over v, which equals, and then we just have 100 divided by 200 kilometers per hour. And that is 0.5. So the whole race just takes half an hour. The first part takes 129.4. So in this part, we can say delta t for the second part is equal to the delta t total minus delta t1, right? And then what we can do is just put in the 0.5 minus, and then this is 0.2941. And we get our answer. So our time is equal to 0.20588, 0.20588 hours. All right, so now that we know that, just putting that in here, let me just write that in here like this, equals 0.20588 hours. So now that we know that, finding the average speed is easy. So v for the second part is just equal to delta x over delta t, which is 50 divided by 0.20588, so equals 242.8. 242.8 kilometers, and then per hour, and then writing a statement, they must maintain a speed of, 243 kilometers per hour for the second half.